screen. We'll just go ahead and show the whole screen. How secure is secure? With Andrew Skinmaker and ACE, Association of Cyber Engineers. Today is October 26, 2020. Disclaimer. Yeah, we're going to talk about some stuff that if you use it on other people's computers, then you would get in trouble. We'll laugh at you when you get caught. But mostly today in class, we're just going to be doing it on our machine. So feel free. If you want to crack your own password, see how secure it is, go for it. All right, so our agenda. The introduction, what are passwords, Unix, talk about Passwd file, shadow, and privilege escalation on Unix. Then on Windows, we're gonna switch gears and talk about Active Directory, Minicats, PowerShell. Then we're gonna talk about the key space. We're gonna go back to about how passwords work. And then we'll talk about Cool and Crunch on generating custom password lists that you won't find on the top 10 million from site lists. All right, so just before we flip the page, what are passwords? Passwords are, basically the focal point of security these days on how we do authentication. It's based on something we're seeing a rise in two-factor, but basically, password is what is going to get you around on every single service, and it probably will remain that way for at least the next 5 years, maybe 10 years, until someone devises a better way to properly make sure that the information that someone is trying to receive is actually given to the correct person, and they have properly verified someone's identity, because we currently don't have the technology to just constantly identify somebody without just that simple password. So we're going to talk about how your local computer understands that. So in Unix, we have what we call a Passwd file. So I'm in my VM, it's a Linux VM, and I can cd/etc, and this has a bunch of configuration files. We care mostly about the Passwd. So this contains a lot of configurations about the Passwd and any user account that's on the system. On Kali, this is going to be massive because Kali comes pre-installed with a bunch of services that you can log into and run. But as you can see, most of them are no login. This is just services that are running as daemons, and if they were to get hacked or anything, there's no reason for them to get logged in. So the system itself can check the Passwd configuration file and know that something's wrong if someone's trying to log in, they just get booted out. And we look at the configuration here where it says the first colon separated is your username and their password, user ID, group ID, user description, user's home directory, user's login shell. So we can talk about this in a privilege escalation standpoint. If I were to make a new user, all I'd have to do is add to the Passwd or the shadow file. I'm not going to show you my shadow file in Kali because then you'd crack my password. And I kind of like that password. It's really long. So we're going to practice with this simple root one. I'm going to add a new user to the Passwd file, and I'm going to give myself basically root privileges. In this scenario, we're going to say that the Passwd file was misconfigured, and I'm a low priv user, and I can now modify the Passwd file by appending to it with the standard out redirection. So we're going to use a tool called OpenSSL. Most Unix machines have it, and we can make this password whatever we want. So I'm going to put clear, then I'm going to actually cd back, and I'm going to hit tmux just on the new screen. And OpenSSL Passwd, so this is just going to tell it what kind of hash we're going to use. And then, what should my password be, John?
Please let me in.
Please let me in. All right. So truncated it to 8 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if this works. I feel like it might not. But, so we can verify what this is. I think it's DES. Yeah. So it's DES. So we can take this output and now use it in our tag. So we'll do echo, and then give our user, we'll call it evil root, and then we'll paste our password, and then I'm going to copy the rest because I don't care. And so the next one is the user ID, group UID. We'll leave it blank. It's going to be a home directory, and then /IC. And now appended it. So if I were to do tail/etc/password, it's there, evil root. So I'm going to switch accounts to someone that's not root, because if you're root, you can easily just switch accounts without password. So I'm going to switch into my Cali. It's just sudo Cali. So now I'm Cali. You can see who am I? Cali. So let's do evil root. It's asking me for the password. Please let me in. And who am I? Root. So that's because it checks my GUID. It says I'm 0, and 0 is reserved for root. We've now privilege escalation into root by adding a new user. If you're on a penetration test, feel free to do this, but always clean up your tracks afterwards, because people tend to not like, easy accounts just lying around that because you blasted a hole through their security. And if you made it something that you always use on someone else's penetration test, someone could go after all your clients knowing what password you use. So we'll go ahead and clean up. We will change them to password. We delete that. Wow, that's colorful. So always be careful when you edit these files. I know what I'm doing, so I didn't make a backup, and I'm also on a VM, so I don't care. If you're doing this on your main machine, then that's a bad idea. So I can see I go back to Cali, and if I try to do evil root, it's not going to let me. So we need back out. All right. So another thing that we can do in relation to passwords is we can configure our sudoers file. So if we do cat/etc/sudoers, this is the file that the system will check to see who has sudo access, which allows someone to masquerade as root and run privileged commands. So if you're doing privilege escalation and you have the sudoers and it's misconfigured, you can now configure to do a no password -all. That way, if the user that you've gotten access to, you don't know their password yet, you do no password. It's just for ease of access. Obviously, do the same thing where you clean up when you're done. But this will basically give you complete root access, and that would also complete the engagement. All right, so pivoting to Windows. We'll just clean up here. Right. So Active Directory. So not everyone's going to have Active Directory. I'm on a personal machine. So when I do net user, it's going to tell me the local accounts on my machine. If I do net user/domain, it's obviously not going to work. I'm not on a domain. My machine is just a standalone. But if you're at work or if you're in a penetration test, most companies use Active Directory if they're on Windows, and it will query their entire domain, and you can look at their users, you can get user information, and you can do things like net user Andre, that's me, and I can look at system information like when did I last set my password, can I change it, and also look at other things like password policy. So in this picture, this password, they have a minimum length of 8. That's always good to know when you're doing recon, so you know, like, oh, I don't want to try any passwords that are smaller than 8. And then, you can see if someone's not logging in often, they might be on vacation. You might reset their password when they come back. And then another tool that you can use to gather this information is called Bloodhound. So you can check that out. Bloodhound. GitHub. Here we go. So Bloodhound uses a tool based off of Neo4j and help you graph out the Active Directory network and find the quickest link to get domain admin. This obviously happens when you have a small, low privilege access to an active domain account. Active Directory. All right. Another tool is Minicats. We're not going to use Minicats today. I think that we will see this later on. We see ASS. So this is a Microsoft structure that they've used, and it basically like creates a seamless experience for users that it will allow them to do like things like single sign-on, look at network files and network shares. That way you don't have to input your password all the time. The problem with that is it leaves a ton of stuff in memory. So Minicats was a tool that was developed as a proof of concept, and now it's widely used by anyone who gets access on a Windows machine. And as you can see here, this command, once you've got Minicats running, you can extract all the passwords that it sees in memory that are used for certain accounts. So like on the domain, we can see like this admin account had logged in and it was kept in memory, and they were able to extract that. Sometimes it's going to be in hashes and you'll have to crack the hash. Minicats is super powerful. I can see us using it because we will be doing things like Kerber roasting. Minicats can do that. You can forge tickets to log in remotely to servers. Pass the hash attack. Minicats is a tool to use for that because it can just extract all of this from memory and super robust. So let's talk about stealing passwords on your Windows machine. So we'll talk about Chrome and we'll talk about Internet Explorer and just save passwords. We'll do Internet Explorer first. It's a little bit easier. You can do it through PowerShell. Sorry, my back's issue. This PowerShell object right here is going to be what we leverage to grab it. So it's going to be windows.security.credentials, password vault, and then we'll also get the credentials, and we're going to select this and output it to a table, and we'll run this in PowerShell. And let me put it. I run that and nothing shows up. I don't have any saved passwords. I don't do that here. And then so let's make an account. So I've got 10-minute mail, and hopefully Reddit lets me make an account with 10-minute mail. I don't have a Reddit account, so I can just show you all. So okay, so it's going to let me do that. Continue. Your session has expired. All right, let me refresh the page. I'm going to sign up. Sign up with my email. Continue. Choose a username. What do y'all want to call this? Ace password crack. Okay, I was like, how's that password taken? And it's gonna be my Ace password. Look, no, I'm not a robot. Oh, all right, votes. Am I missing anything, John?
Yeah, it looks fine.
Verify. Not a robot. Click sign up. All right. And then to the mail, inbox. There we go. Apologies if any of these ads are inappropriate. I can't control that. Verify link. All right, so I'm gonna click on that link. All right, so I'm verified. Okay, so I will log out. I forgot the password already. This is not good. I forgot the account name too. This is big, not good. Oh no. Okay. Yeah. Okay. We're back here. Ace password crack. What would I make the password? My Ace password.
Good question.
All right, there it is. Okay, so if I click here, I'm gonna hit save. All right, so I can save the password. All right, I'm glad I remembered that. So now I can go here. Let's rerun the command, and it should bring up a pop-up, please. All right, let's try it on Internet Explorer. I might be selecting the wrong thing, and I did this on Internet Explorer on my work machine. Everything's going to save things to a different place, so you just got to be careful like what you're selecting, and know like what you're grabbing it from. So in this case, I did not grab it from the right place, I'm guessing. Wow, Reddit. Okay, log in. My ace. Wait, no, it was my ace password, and then this one was who am I? Ace password crack. Log in. All right, yes. All right, so I clicked yes. This is an ugly website. Wow. On Internet Explorer. Let's try it again. There it is. All right. So I'm guessing the password vault acts a little differently on Edge instead of Internet Explorer. And my guess is because Edge was developed on the Chromium framework, so it's probably going to be in a different spot, and it's probably going to be a similar process to Chrome. But as you can see right here in clear text, I've been able to extract the passwords. So a lot of people will use Internet Explorer on their work machine simply because that's what IT gave them. If they're saving their passwords, that little one-liner is going to be enough to extract all of their saved passwords in clear text, and now you can use it to compromise whatever accounts they got. So that is extracting Internet Explorer passwords. I'm going to clean that up. All right. And then on Chrome, so I'm not going to do this on Chrome because I actually do have a few saved passwords. I'm not going to show you all those, but this is similar to probably what I'm guessing Edge is going to be. And you can just go on GitHub and you can get the script. Obviously, don't run it unless you understand what it's doing. But I read through like what this guy is talking about, and they go line by line or section by section to break it apart. You need two libraries, PyCryptoDome and PyPy132, and that's going to basically help you decrypt, because that's how Chrome bases it off of the Windows account user that saves the password. It's going to use that secure string to unlock the database, which is exactly what you see here. They grab the key from the local state path, and then once they have the key, they can encode it and use the key later on to decrypt the password that Chrome has stored in the SQLite database. SQLite is just pre-packaged. It's right out of the box for Python. So all you really need to do on one end is grab the token on Windows, and you can just copy the database, and you can do that cracking on your own machine. Or you can just run this locally, but obviously, if you run it locally, that's going to leave a big dirty mess behind you. All right. And then using your password knowledge. So this is how you create a login object that you can then use later on to switch accounts from PowerShell to another account. And basically, you will store a string, call it your username that you probably compromised, and then use your password. And then it's not as simple as Unix, where you just like pass in the string. On Windows, you actually have to create a secure string object, and you do that with the secure string password, and you make sure it's that object, and then you convert it to secure string, and then give it those tags as plain text and force, and then to create your credential object by passing in this secure string. And then if we were to look at this object, it would tell us that it is a secure string object or a credential object that you can then tack on as a flag in your commands and run as a different user. And it'll have all those attributes in PowerShell. So I could copy and paste this and look at it. So it's going to work. Like, it doesn't have to be my username is an account. It's all like algorithmic. It's an object. So we can look at the cred object, and that is a system security secure string, and then sec string password. That's just a system security secure string. It's not associated with anything. So that's why I had to pump it into the object that would have these attributes. Right? And that's Windows. And then let's talk about passwords. So everyone's seen this XKCD. I'll let y'all read it. Basically what it's saying is you can either have a super complex password or you can have a really long password. And people have thought for a long time that the complex password, because it's hard for them to remember, it'd be hard to guess. But actually, if it's short and complex, it's going to be way easier to crack. So this was published by the SANS Institute, and they do the math for you looking at the key space, because it comes out to be you have 26 lowercase numbers. Well, if you have letters, if you have numbers and letters, then it's 26 plus 10. And then you use some set math, and you see that it's actually 26 plus 10. Raise that to the power of 5 if you have a 5-character password, and then use the knowledge of modern GPUs, and they can do 200 million operations per second. This is just a CPU, so it can destroy these lower passwords. And this math, you can update it as it goes, as you see, like they really easy inputs on seeing how easy it is to crack a password just with pure brute forcing. And we'll go into that next week. I think we're doing Hashcat, and that's how we can use a GPU that's been optimized for cracking and just generating passwords that have never been made before. But we're going to talk about creating a custom word list. So in our scenario, we found a person that is super into a topic, and we know that they probably make their passwords based off of that. So we can use a tool. It's built into Kali. It's called CEWL or CEWL, and do --help. So we can see all the options for it. There's a ton of options, but basically I can give it a website to crawl, and it's going to give me back some words, and I can use that to pump into my word list. So we'll do these arguments. So I'll give it an out file. We'll call it cool.out. Depth is what it looks like when it's crawling. So if I am sending it to Wiki and it sees a link from, let's say I start at United States, and then it sees a link to a sub-state like Louisiana, and then another link to the colleges in Louisiana, and it clicks on Louisiana Tech. I can give it a depth to say I don't want to go further than 5, so don't click on any links on the Louisiana Tech page. Or I can give it 0 and just look at the page I'm giving it. I think the default is 5, so if you only want to look at that one specific page. John, you got any websites you want to crawl and look for default passwords?
Off the top of my head, I would say Reddit, but that's really
I don't know
broad.
how Reddit's gonna work, but yeah, let's try it out. Let's see. Yeah, let's log into Reddit here and see what happens. Is there a cybersecurity subreddit?
It's bound to be.
Oh, if you type in C, apparently it's going to hotkey. Let's go to the OSCP subreddit. That's I went on that. All right. Let's see what happens if I just copy that. I'm not sure if this will work. Cat cool.out. So it got a few things. It saw some words that it thought were important. These are obviously not important to cybersecurity. Let's try that again with a better link. Let's click on here. Let's look at
I put FireEye or whatever.
You want to do FireEye?
Yeah, sure.
All right. Thanks to Google results, I wanted FireEye. Oh, it's Bing. It's Bing. All right. We'll try FireEye. Oh, this might be interesting. So I can see security and threat. So if I do cat, pull that out again. Some of it's going to be good, some of it's going to be bad. It's like nation state. Those might be good if you're looking at cybersecurity, like one threat actor. There's a lot on here. This is good. Adaptive effectiveness. You want those keywords that people might like. One example I saw while looking at it, they used the Game of Thrones wiki. So I could give it this. And it's like if they're a big nerd and they use they like Game of Thrones a lot, you might want to use that as a starting point to guessing some passwords. There we go. So like then you have like the battle, the invasion, the Andals, and their password might be like Andal 381. So if you want to talk about guessing that, so cat, pull that out. Yeah, these are some good things. Well, not all of these, but so go to the next slide. Get rid of these. And this is Crunch. So Crunch allows us to basically do that set math on creating all the different generation of combinations that you could have. So let's just do Crunch with the min length and max length. So I can say like I want you to generate every combination of passwords that are like according to our rule set. The default rule set I think is just letters maybe. And then I want it to be like, let's say I do min length of 3 and max length of 3. So I'm just going to create 3 character passwords. Oh, that's going to be big. Oh man. Okay. So let's see if that math was right. What did it say? Oh, I was going to be really long. Let's not do that. But I think that's 26 times 26 times 26. So we do calculator. 26 to the third. I don't think I have. It's on programmer mode, so we'll just keep doing this. I think that's the number that I saw. Was it 17,000? I believe it was. I'm not sure. Which if we go back here, this is exactly what that math is doing. It's looking at the lowercase and it looks at 3, and you saw how easy it was to crack, like to generate that list, passing that output into a hash cracker. Once you know that hash, it's going to be trivial to solve that. So then Crunch has some different properties. So I can do 3, and we'll do -t, and this is going to be a pattern. So I can say I want it to be some letter and a number. So I'll put A, and then I think pound. That'll be 2 numbers. So it's going to go through 0 through 9. Oh no, it's going to go with that symbol. But the A, the alphabet at sign. Let's see what the help is. Let's see. So crunch, man crunch. So we do we want to tac -t. So uppercase characters, numbers. All right. So if we know that like our password is going to be 8 characters from the password policy, and we already cracked one, and it's the person's last name and then like some numbers, we say like, okay, I want alpha, 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 or whatever, and then 4 numbers for the year. Is that 8? I put too many. It'll now generate. Wow, no, we're not generating 38 gigs. But essentially, it's going to run through the 0 through 9,999, and then A to Z for every 4 of these, and generate that key space. So we can calculate that with our calculator. Let's use standard. This would be 26 to the 4th. There's no powers on this one. Is it scientific? Yeah. So 26 to the 4th times 10 to the 4th, and that's correct. So you can see how like that key space is in action. There's tons of other options, as you saw when we did man crunch. I think crunch -s maybe. I do like cybersecurity rocks. I don't think I put a min of 3 and a max of like 25. Minimum length should be 5. Okay, go ahead and get that. That's not right. Is it dash P? I think it's dash P. Sorry, guys. I'm not the expert on this tool. 6. All right, so this is going to generate all the combinations of the words cybersecurity, rocks, and yeah, cybersecurity and rocks. So you have like the cyber rock security, cybersecurity rocks, rocks cybersecurity, and it goes down. And so you can pass in that list and generate random password. So one of the ways that you can use this to generate a super long password is I could say that I want to generate, this crunch 25, I want to generate password that's, at least 25 characters and max, I don't care, I'll put like 60. And I could pull that dash P in from a whole dictionary list with the dash P. It'll just combine those randomly for me. I can just grab one and there we go. That's a super long password that, according to Sands, is going to be hard to crack unless someone has already generated that word. All right. Thank you for coming and watching the presentation. That is an intro to password cracking and leverage.
Thank you, Scoot.
No problem. How do I hit stop recording?